a value must be more than 1.5 times the interquartile range away from the upper and lower quartiles of the data. So one thing we did not actually write down, we need to right now, let's squeeze this in right here. Interquartile range. It is often just referred to by the letters IQR. It is Q3 minus Q1. Third quartile minus first quartile. Okay, we might also want to write down right here what the what just the range is. We had that on the very first notes because in a while. Range is just the maximum minus the minimum value. Now, there are a lot of times we would rather use interquartile range than just the range. So, range is going to be very, very, very susceptible to outliers, right? So if we are taking the height of everybody in the class, and then, you know, like Shaquille O'Neal walks in the door, right? He is really tall, and so our range would look much bigger than it actually is, right? Because really we would probably have a much smaller range. But if we looked at the interquartile range, it probably would not change that much, right? Because when we're looking at the interquartile range, we're just looking at the first quartile or the third quartile minus the first quartile. It's the length of your box on a box plot. Okay? So, so the range on this range would be from this blue line to this blue line on the end. The range of this data is really big. Interquartile range is a little bit closer, right? Interquartile range is better to use if you have outliers. Range is perfectly fine if your data is really normal and doesn't have any outliers there. So let's talk about what it means for something to officially be an outlier. So it must be to be identified as an outlier. A value must be more than 1.5 times the interquartile range away from the upper and lower quartiles. So interquartile range, I said, was the box, right? So I'm going to take, I can do this right here. I'm going to take this box, I'm going to copy it because I can. I'm going to paste it. So like that length right there is the length of my interquartile range. So for something to be an outlier, it would have to be 1.5 times higher. Let's see if it'll let me. Oh, it's not going to do that very well. Well, let me do this. I'm going to just make a box that looks like it's about half of that. That's close enough. Right there. So it's running off of my page here. So I don't actually have any upper outliers for this problem, right? Because I've got 1.5 times the interquartile range. I definitely don't have any lower outliers because that lowest number is not even a whole box below, right? So this data set right here that we're looking at, it does not have any outliers, okay? Because if I take the box and add it to the top here, my whisker does not go past that. What do you guys think about this one here? You think it's going to have outliers? Okay, Marley says so. I'm seeing some no's. Okay, let's do the same thing. Let's take the box. Change its color. All right, so if I have, there's one whole box. I'm just going to copy and paste it again. There's 2 whole boxes, right? That's definitely more than 1.5 times the interquartile range. So I would have upper outliers here. And for lower outliers, I don't think I would have any, but it would almost be close to having lower outliers as well. If I take and make that like half the length. It's a little bit bigger. There. So whenever you're thinking about whether or not something has outliers, you need to be thinking about how those whiskers, how those lines on the end compare to the box in the middle. So like our line right here on the end for this problem is not as long as our line over here, but the box is really little, right? So that's telling me most of my data is very close together there in the middle. But over here, this is really long. Okay, so I want you guys to look at these 3 box plots and just tell me if they have outliers. Okay, we don't have actual numbers. Tell me if they have outliers. So look at all 3 of them. I want you on your paper to write down whether or not you think they have outliers. Okay, so Zane, what do you think for that first one? Okay, Zane says no for this one. I would agree, because if we look at the length of that box, we don't even have a single length of the box right there for either one. So I would agree. No, looks good for that. Okay, let's see. Ayla, what do you think for the second one? Do you think that one has outliers? Okay. Do you think they are high outliers or low, or both? Okay. So, so for this one, we're wanting to take that box. That is one length of the box, right? Then we're going to take a second box. We only want half of it. So let me see if I can make it like half the length. Close to half. Right there. So this length right here, from here to here, is 1.5 times the length of the box. Do we have any data points that go beyond that? We do, because our line goes out further than our boxes there. So this one would have an outlier that's high, right? This long whisker over here, that would be a yes, and it would be high outliers. But if we look at the other side, if I take the length of that box and put it here, my whisker doesn't go past that box, so I wouldn't have any low outliers. Okay, so I would say yes for this one. Okay, Presley, what do you think for the third one? Okay, no? All right, do you guys agree? All right, what do you think, Peyton? You think it's yes? What do you think, high or low outliers? Low. All right, so let's check. If I copy this and paste it, so like if let me make this box a different color too. So here's the length of one box. And then if I make another box that's slow. You're right the first time. If I make this box about half the length of that box, that's pretty close. Right there. Alright, so that's 1.5 times the length of the box. I've still got numbers that go below that. So this would be a yes, and it would be low. You would not have a high outlier here because if you look on the high side here, the higher numbers, that whisker does not go past the box. So when you have a whisker that looks really long compared to the box, then that is when you're going to have an outlier there. Now let's look at how to do this with numbers also. So this is your test for outliers when you don't have a box plot to look at, or if you're needing to be really precise. It's going to be, for your upper limit for outliers, you're going to have Q3 plus 1.5 times the interquartile range. For the lower limit for outliers, you're going to have Q1 minus 1.5 times the interquartile range. All right, so we just have a data set here. It's just the generic data set. We don't know what it is. Do you think, looking at just the numbers, does it have outliers? What do you think, Julian?
Yeah.
You think so? What numbers do you think are outliers? Uh-huh. What number do you think is an outlier? Or numbers? Three's definitely, so when we're talking about outliers, we're talking about the numbers on the end that are far away from the rest of the data. All right? So it would have to be the numbers on the end. So it'd have to be like 0 or maybe 22, maybe 19. Those are possible outliers. Okay? Maybe. 22 seems a little bit big, but we want to compare it to the rest of the data. So to test, we need to know the quartiles and the interquartile range. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers here. So that sixth number right here, there's our median. So then we can, once we find our median, we can find our quartiles. So, Laura, what's the first quartile going to be? 1, right here. There's our Q1. And then, let's see, Hank, what's our third quartile going to be? 15. All right, so for our interquartile range, the IQR, we just do Q3 minus Q1, which third quartile for this is 15. First quartile is 1, so that gives us an interquartile range of 14. Okay, that's the length of our box. Our box is 14 units long. So if I want to check to see if I have an upper limit, for the upper limit, I would take Q3 and add 1.5 times IQR. That's the formula that's up there for you. So third quartile is 15. And I do 1.5 times, Zane, what was the interquartile range that we found? 14. Right, so if I do 15 times 1.5 times 14, well, I get there. I get 36. Okay, what this tells me is a number would have to be greater than 36 to be an outlier for this data set. Do we have any numbers that are outliers? No. 22 is not an outlier. It is our highest number, but it's not our outlier. It's not an outlier. So we don't have any upper outliers. We need to also test for lower outliers. And for the lower outlier, you're going to take the first quartile, and this time we're looking for numbers lower than that first quartile, so we subtract 1.5 times IQR. So Zach, for this data, what would we do to find that lower limit? Okay, 1 minus 1.5 times 14, and that is going to give us a negative number, negative 20. So what this tells us here is a number would have to be less than negative 20 to be an outlier for this data. So we could conclude here that we have no outliers. Okay, questions? Okay. All right, so I need you to figure out if there are any outliers for these data sets. We're going to do the first one together, the second one on your own. Let's just look at it first. Example 3, does it look like there's an outlier? Okay, Owen say no. What do you think, Jada? The 51? Yeah. So we're thinking maybe the 51. Let me check on what Caroline says here. Maybe it's just... Okay. What's that? There we go. All right, so maybe that 51, maybe even the 4. I'm not 100% sure. So, let's use Desmos for this too. I want to show you guys how you can use Desmos as well. You can do it by hand or you can use Desmos. All right, everybody get your heads off your desk. Gavin, Julian, everybody with me? Julian, put your head up. Okay, all right, so let's just call this A equals, and then 4, 10, 25, 28, 29, 30, 30, 32, 51. All right, so if I want to know the 5-number summary like I would need for a box plot, I can get this to make a box plot. Or if I just want the numbers, what would I do? Stats. S-T-A-T-S-A. Okay? So, Q1, does it do IQR? It probably does. Okay. Let's see. Also, I meant to show you this as well. If you look at the keypad and do functions, under statistics, you've got a lot of different options right here. So if you're not sure, it has a lot of them listed. It may not be all of them because stats is there. I don't think it does interquartile range. No, it doesn't. But we can figure that out really easily. So, interquartile range, we would do our IQR would be Q3, which is 31, minus Q1, which is 17.5. So that gives us an interquartile range. 31 minus 17.5 is going to give us 13.5. All right, so we need to look that much above Q3 or that much below Q1. So for my upper limit, Owen, tell me what to do. Yeah. To find that number that it can't be any higher than this, or if it is any higher, it is an outlier. How do we do that? We start with the formulas on the last slide. Quartile. Okay, so we'll do 31 plus 1.5 times that interquartile range, which was 13.5. So 31 plus 1.5. Please make sure you're writing this down and know how to do this. I get 51.25. Is 51 an outlier? No. Is it almost an outlier? Yes, it's really, really close to being an outlier, but it is not. It is not technically an outlier. Right? It doesn't pass that test. I don't feel like there is a lower one, but let's check it just in case. Ayla, what are we going to do to find that lower limit? We got to, so the formula that we saw on the last slide here is Q1 minus 1.5 times interquartile range. So we got to use our Q1, which is 17.5. So we'll say 17.5, and then we'll do minus 1.5. And what do I multiply that 1.5 by? The 13.5. And whenever I do that, I get negative 2.75. Do I have a lower outlier? No. So no outliers. So 51 seems like it should be, but it's actually not. All right. You guys try data set 2 on your own. Numbers in an order, you can find the quartiles on your own, or you can. It's going to be, so since that number is the middle number, you're going to kind of take it out. So it did fall between 2. Take that out. So you have 3 numbers here, so just that. Okay. Yeah. Find the quartiles. So find the quartiles, you have to find the median first. So what number would be your median? Good. We'll circle it. Okay, so Third quartile minus first quartile. Okay, so whenever you do this, you should get the median is 267, first quartile is 234, upper quartile is 301. So interquartile range is going to be 67 when you do 301 minus 234. So upper limit is 301 plus 1.5 times 67, which is 401.5. Do we have any upper outliers? Yes. 445 is an outlier because it is bigger than 401.5. All right, for our lower limit, we're going to do 234 minus 1.5 times times 67. It gives you 133.5. Do you have any lower outliers? We also have a lower outlier here for 102. If you put this data into Desmos, oh, yeah, that's right. If I do a box plot, and let's change this. We need our x to go from 0 to 500 so we can see it. It makes a really strange box plot, actually, because Desmos, if something is an outlier, shows it as a dot instead of showing it as that line. Like if I make these numbers smaller, like if I make that 140 and I make this one 345, you can see it goes back to being a line. But if they're outliers, it shows them as a dot, which this is a small data set. So, so if you do a box plot, it'll show you whether or not those are outliers. If they show up as dots, then they're outliers. There. All right, we're going to do one more data collection today. I need everybody to count up how many first cousins they have. I always get this question. I'm shocked that you guys do not know.
If it's your aunt or your uncle's child.
Yes.
So if your mom
All of your mom.
sisters, their kids.
Yeah, your mom and dad's brothers and sisters. It is their children. So your aunts and uncles, their children.
My question is
Yeah, I mean that would be what you call your cousins. They're because I want there to be some outliers. Yes, let's count. Count if you can count them. All right, so I need you to count up all of your first cousins. In a second, I'm gonna count mine too. Alright, so everybody counted their first cousins. I've got 15. Katie, how many have you got? Alright, Hank. Julian.
3.
How many? 10.
3.
Okay. All right. So we have this data. I'm going to put this into Desmos so that we don't have to put those in order. Okay. Bracket in the wrong place. All right, so we've got our data set. I'm going to do stats. A, it's going to give me my quartiles. All right, so we want to answer the question, do we have any outliers? So if we do, it's Marley with 17. And so, or I guess there's a chance, maybe I could be with 15, but I don't really think so. So I need to find the interquartile range. Vince, how do I find the interquartile range for this data? Not median. So interquartile range is just, so you guys need to know this. All right, so pay attention right now. You got to be able to find this. Interquartile range is third quartile minus first quartile. For this data set, Q3 is 12, Q1 is 4. So 12 minus 4 is going to give us 8. So we have our IQR, interquartile range, is 8 for this data set. Okay, so Cameron, for our upper limit, what are we going to do for this data set? 12 plus 1.5 times 8. Okay, what do I get? 24. Do we have any upper outliers? No. All right, lower. Katie, how do I find the lower? And what do you get? -8. No one has -8 cousins, right? Ever. So we do not have any outliers. Now, if we went back, the number of cousins people have is really declining here. So if we went back to like my grandparents' age, or just my parents, my grandpa had 10 brothers and sisters. So that means that my dad had 10 people, all of their children were his cousins. So if all of them had just 2 kids, right? If all of them got married and had 2 kids, then on just his dad's side of the family, he would have 20 cousins, first cousins. And that's not counting his mom's side of the family. I think my grandma had 5 brothers and sisters, or was one of 5. So there's another 10 first cousins or so. So my dad, they probably all had more like 3 or 4 kids apiece. So my dad has so many cousins. There's lots of people that I don't know that are my cousins. Whenever I go back that far, right? Now if I go to like, they're not my first cousins, but they're like my third cousins because their kids' kids. Lots of people I don't know that are my cousins. But households are smaller these days. You typically don't see people with 10 children, so number of cousins is smaller as well. But if we included my dad and his 30-some cousins, he would probably be an outlier here. So, all right, so let me give you guys the assignment. Do not pack up. We have 12 minutes left. Caroline, I'm going to let you go ahead and get off of here. That worksheet that I gave you is going to be the assignment for that. So you can log out whenever you're ready there. You are welcome to use Desmos on this if you would like. I think I did put the data in order for most of these, so it's not that hard to do it by hand either. But you are welcome to use Desmos if you would like. Variable, equal, and then the bracket. Yes, do A equals, or whatever letter you want to use equals, and then do the square brackets and do your list. For your interquartile range, yes.